Hi, everyone. Welcome. I know there was another Kotlin native talk yesterday. I hope some of you went to see it. I got to see the slides. I unfortunately arrived late, so I couldn't see it in person. Um, Unfortunately, we had to move the talks a little bit around, so this would be better as an intro talk that would go before the other one. However, I'm going to be talking about Kotlin multi-platform projects and Kotlin native from a slightly different angle. So if you went to the other talk, it's all good. This is going to be a more high-level intro on how to think about building an app for multiple platforms using Kotlin multi-platform. But before we go into that, let's back up 5 years and let me talk a little bit about my personal story of trying to build a multi-platform game engine. So at some point I thought, I was building mobile apps, I was using Java, I was feeling quite comfortable with it, but I thought, as an engineer, as a programmer, I never really got to learn C and C++ on a level that I would have liked. And so I thought, I had this great idea, why not learn it by building something like a cross-platform portable game engine for simple 2D games, and try to build it for Android, iOS, maybe Windows Phone, maybe for the web, and even run it on desktop on Linux, and do it in C and C++ just to learn it. Because why not? Because we all just want to learn new stuff. So I went with that. I had a few friends helping me. And the way I thought about this was, a game engine, consists of some common utilities that you always use, like math operations, collections that you will use to hold your objects, and then the actual classes that you will use to build your game. So building a scene graph, so what happens on your screen, some sprites to show your player on the screen, your enemies, some backgrounds. Then you probably need some kind of resource manager to load your textures and so on, and be able to use them on the screen. So this is all shared. This is what you use when you actually want to build the game. But then, once you actually want to run the game on a specific platform like Android, iOS, or Windows Phone, or the web, you actually need access to some platform-specific interfaces to actually show something on the screen, to render it, to play some sounds using technologies like OpenSLES on Android or maybe OpenAL on iOS. You need different ways to load files. So on Android, I probably want to be able to open Android assets, whereas on the web, maybe I will load my textures from URLs as files. I need something like persistence, so a key value store. Again, on Android, simplest way, just use shared preferences. Maybe on a web browser, that would be just local storage on the window object. So we see these two parts, right? We have this shared code and this platform-specific code. And so I started implementing it with the help of a bunch of friends. And so first of all, I started writing portable C code just to have my collections, my array lists, hash maps, whatever. Then my game engine classes such as scene graph, sprites that I would actually use from my game code. So let's say I implement a 2D platformer. So I would use these scene graph to build my screens, to build my game, and put my game logic also in the portable code. But then whenever I decided that, let's say I want to save my game state to disk, or I need to render my game to the screen using some OpenGL graphics or something else, I would try to define these interfaces that I would use from my game code, from my game engine code, to be able to actually do it. So these would be the header files with my interfaces for, let's say, something like persistent storage. Then, on the other side, I would need to have matching C files for these header files that actually implement the code for, let's say, saving something to disk. And on Android, we could probably use something like OpenGL to draw, or, like I said, go through JNI and use shared preferences to store simple key values. And so we see, just like I described, we have this bunch of common code that I compile for all platforms. And then I could write the Android-specific part because I know Android. And then, on the other hand, I could ask my friend who knows iOS, who knows what they use for something like key values. Instead of shared preferences, they probably use something like NS user defaults. And he could help me build this iOS part while not even touching the left side, the common portable code, which runs everywhere. How does this work in C? You don't have to understand C or know it, but more or less, the header files, like I said, they just define the expected function signatures that I will use. So if I want to have a key value store, I probably want to have something like put string with a key value, and I want to be able to read it back. Now on the platform side, someone goes and implements the storage.c file where they put the actual implementations. So for Android, that will be calling through JNI to our Java side and actually implementing it using something like shared preferences. Now this will be important for the later part of the talk where I talk about Kotlin. So bear with me. So for games, this was an exercise for me to learn. This kind of worked. We got it to run on many, many platforms using this shared code base and help from people who actually know how to implement stuff on Windows Phone, or on iOS, on the web browser. But for games, this was a pointless exercise because this problem is mostly solved with middleware such as Unity or Unreal Engine, things like that, where they actually provide you all the shared code that will run on these various devices, and you literally just implement your game. And that's fine. Like this is solved. Games are a little bit different from apps. They usually take over the whole screen. They just draw your whole game without taking into account the platform-specific widgets, differences between platforms. Sometimes they even can ignore things like life cycle. You either are playing your game or you quit the game and you're not playing it anymore. So it's a lot easier in a sense than building apps. Okay, so getting back into apps, because that's interesting for us probably. For building cross-platform apps, there are many frameworks, toolkits, however you name them, available that tell you that you can build an app once and then run it on many platforms. We all know Flutter, Xamarin, React Native, Cordova for building HTML5-based apps. We've probably all heard about them, tried them. Now, I have to say, I'm not a big fan. And I understand if someone's using them, they can get really good effects if you know how to use them. I'm just not a big fan. I was trying to find something else. Now, why? Just because many of them come with their own widgets that maybe don't fit in well with the platform, or they use platform widgets but in a weird way, or they take over the drawing completely, just like a game. So they treat the screen as a canvas and they literally draw everything themselves, which sometimes just feels weird when you look at an Android app and an iOS app, and they don't really feel native. Now, they use various approaches to running code. They can be compiled, they can be interpreted, they can run in a web browser. And they use, of course, different languages. So you can see Dart and JavaScript. And in a way, there's a big impedance, so like kind of a mismatch between the platform languages, such as Java or Swift or Kotlin, and the languages you would use there. And actually, sometimes you need to connect back to the platform to use some specific interfaces that are maybe not provided or not available or built into these frameworks. So you need various bridges, channels, going through JNI or other interfaces to actually call back into the platform code, and that's not ideal. Okay, so I thought, is there a better way? And now that we're all building our apps in, well, not all, most people are starting to learn Kotlin or are building their apps in Kotlin already. How can we leverage that language and the way you can build cross-platform apps in Kotlin? So let's talk about an example. Let's build a Sudoku app for Android, iOS, and the web. Thinking about building a quality native experience for each platform. So the user interface, the application shell will be native to each platform, because Kotlin Multiplatform is not a cross-platform widget toolkit. It doesn't provide you the user interface part, and that's great. That's actually what I wanted. What I want is to have as much code sharing between platforms as possible. So thinking about business logic, about my models, stuff I will talk about in a second, as makes sense for my app without actually trying to build one app that runs everywhere, because I want it to feel native. And we will be taking advantage of the three flavors of Kotlin. So Kotlin JVM, this is the one that we probably all know and use on Android. This is the Kotlin that gets compiled down to Java bytecode, and then on Android it gets transformed into Dalvik code, bytecode, and runs on something like Art or Dalvik on earlier Android versions. But then there's two other compilers for Kotlin. There's Kotlin Native, which can compile Kotlin code down into native machine code that runs on the device itself. And then there's Kotlin JS, which can transpile Kotlin into JavaScript code that can run on the browser or even on something like Node.js. Now, for the purpose of keeping it simple, in this presentation, I will be talking about Android and iOS. However, in the project that we'll be talking about in the GitHub repository that I will show you, all of this actually works in Kotlin.js as well. It's just that there's no point of showing 3 parts on the screen. It's just easier to talk about the 2 parallel mobile apps. Okay, so let's jump in. And how do I think about building a Sudoku app? So if I were to do it in a world before Kotlin Multiplatform, before being able to share code between platforms, I would probably think about structuring my app like this. So I would have 2 applications, one for Android, one for iOS. And then there's some, of course, building blocks that look similar on both sides. So going from the top, of course, on Android, I have an application, an activity. On iOS, I have the native iOS application project, the view. Then I probably go down to some view model or view controller on iOS. And to call down into the lower layers of my application stack. And then finally is my Sudoku app logic, which consists of, first of all, a Sudoku solver. So this is the part that generates my Sudoku boards, that lets me solve them, check for errors. Basically, it deals with all the game logic of generating and playing Sudoku as such. And then I thought it would be nice if my application could also save the progress or save the board that the player is playing right now to disk. So I need to, first of all, serialize it in a way, something like JSON maybe, and then save it to disk, so persistence. So I need both of all of these on both sides, right, on iOS and Android. So how do I think about then sharing some parts of this between platforms? Let's take the easiest part first. Let's talk about the Sudoku solver. Now, the Sudoku solver, this is just math and logic. This doesn't need any platform-specific calls at all. This is just calculating some mathematical operations, just some logical operations to figure out how the board will look, what the numbers will be, and how to solve them. Now, in my Android project, you could think of it in a Java world. That would probably be a JVM module. It doesn't even need the Android plugin because it doesn't call into the platform at all. And so it's actually easiest to take it out and make it a Kotlin Common module. Now, Kotlin Common is actually a 4th flavor of Kotlin, which, like I just said, doesn't have any platform-specific calls. It's just Kotlin code. Now, the main difference is, so I previously said there could be a JVM library in my project. The main difference is, from a Kotlin Common module, you don't have access to the Java core classes. So I can't basically use any classes from the JDK. I can, however, write it in Kotlin code that uses Kotlin Common modules. What do I mean by that? Now, if you go into the documentation for the reference for Kotlin classes, and you mouse over any of the Kotlin packages, you can actually see which flavors of Kotlin this package is available for. So you can see native, JS, JVM, and if it's available for all these 3, that also means it's available in Kotlin Common, and I can actually use it in this type of module. So for Kotlin Common, like I said, first of all, you have a large part of the common standard library of Kotlin available. So you have classes like collections, math operations, pseudo-random number generator, which I'm using to generate my Sudoku boards as well, regex, text manipulation, and so on. So a large part of the Kotlin standard library you can use in the Kotlin Common module that you can compile for both platforms. Now, there's other interesting libraries that come from JetBrains that are actually multi-platform enabled. One of them is serialization that lets you serialize objects in an easy way into formats like JSON, protobufers, and even more custom formats. Then there's Ktor for asynchronous HTTP operations, both client and server libraries. And there's even more third-party libraries popping up, such as SQLDelite for persistence, for dealing with databases that has drivers for both iOS and Android. And I'm sure there will be more and more. So thinking about this, let's move to the next section. So serialization, like I just said, another way of making sure that your part of your app is multi-platform, instead of writing it yourself, instead of moving it to Kotlin Common Code and trying to share it, why not just use a library that's already available? And Kotlin X serialization does just that. I was able to use that. It just works on both platforms. It gives me JSON serialization for my Sudoku game objects, for my Sudoku boards, so that I can share it between platforms. Now, before I move on to the next section, let me just show you how this works in an Android Studio project. So for my Sudoku solver, I have it as a module in my project. This, like I said, contains just my Sudoku game, Sudoku board code. This lets me generate boards, solve them. It has some common operations. It's all just logic and maths. And the way it's, the way it looks in Gradle is it uses the JetBrains Kotlin Multiplatform plugin for Gradle, which lets me build this as a multi-platform module shared between these platforms. Now, to define the devices that I'll be targeting, you use presets. So here, because like I said before, this isn't actually an Android module. This just contains, let's say, JVM code that doesn't call into Android. I can use the preset JVM that can be used from an Android project. Now, of course, I have a JS one for the browser, and then I have an iOS one for building a native library in Kotlin native for iOS. Now, because like I said, I don't have any platform-specific calls here, you can see that all my code is in a special source set that's called common main. That's where you put code that does not depend on any of the platform-specific interfaces and can only use the Kotlin standard library that is marked as available in common code. Now, just to show you how easy it was to add serialization to my app, I simply depend on that library. It is a multi-platform library. It does have implementations for all of the device types that I'm targeting, and it was as simple as marking my Sudoku game as serializable, and then it provides you classes for actually transforming that object to JSON and reading it back. So that was super easy. I didn't have to write it myself. Okay, now let's go back and think about persistence. Now, I told you that there is a library for persistence. One of them is SQLDelight. It deals with databases, though. But I just want something simple. Since my Sudoku board is just a bunch of numbers, it's very small data. Normally, I would probably store it in shared preferences just to not make things complicated. I want something similar for both platforms. Now, remember how I told you about how I implemented storage for my game engine 5 years ago? Actually, it looks eerily similar in Kotlin. Now, in Kotlin Multiplatform, you get two new keywords, expect and actual. And it looks very similar to how we define headers that declare the classes, the functions that I want to have. So I want to have a getString function to read a key value, and a putString function to be able to save something. And I define it in my common source set using the expect keyword. And then I go into each of the platform-specific source sets. So I have an Android main, I have an iOS main source set, and I provide the actual class implementation that will be used when I compile for this platform. So on Android, I have this same multi-storage class with the same functions, except now I have implemented the actual body of the functions, and I can even add something like more properties. So here I use shared preferences. Now, for iOS, it's actually interesting because I don't have to go and write code in Swift. I can go into my iOS source set and implement a similar multi-storage class in Kotlin that, again, uses the actual keyword and implement my iOS version of the storage using NSUser defaults. Now, like I said, I'm not even going into Swift code here. What's nice about using Kotlin native with the iOS target is that it actually provides you with all of the iOS frameworks that you could use from your Swift code, from your Objective-C code. And in that sense, I can just create an NSUser defaults object, which is part of the iOS SDK, here right in my Kotlin code, and call methods on it. So that's great. By the way, I forgot to preface this presentation by saying that I've never done an iOS app in my life before. I started learning it 4 weeks ago just for this, and I was able to prove that with minimal knowledge of just being able to create a project in Xcode, and without actually going into Swift for most parts of my app, I was able to run it on iOS. So okay, it was easy for me to provide this multi-storage implementation for both platforms. And by the way, how do you know if you can use specific classes from the Kotlin standard library, let's say on Android, on iOS, or in JS? Again, we go back to our reference documentation for Kotlin on the Kotlin Lang website. And again, you can see these small pills that tell you that some interfaces are only available per platform. So for example, when I was implementing the same multi-storage class for JS, for JavaScript, for running my Sudoku game in a web browser, I would probably use something like window.local storage, again, to save my key values to the, well, to save the game state. And of course, something like browser document, browser window, it just doesn't make sense for any other platform. That's why it only exists for the JavaScript version of the Kotlin compiler in the Kotlin browser package. Okay, so now we've moved most of our, let's say, lower levels of the application, our business logic, our models, into common code. But as you can see, even from common code, in our persistence module, we have the parts that are responsible for actually dealing with the platform-specific parts. They have a shared interface. They have various implementations for different platforms, all written in Kotlin. So here's the end result. I was able to keep the native interfaces for Android, for iOS. Of course, it's ugly for iOS because it's the first time I'm building an interface there. The nice thing about having this shared logic, about having the same code that generates the boards, that solves them, and so on, is that now, for example, my board generating logic, like I said, is based on a pseudo-random number generator that is seeded. Now, if I use the same seed, the same number to start generating the board from, if I do that on both platforms, you can see the boards look exactly the same. And so that means sharing, let's say, game state or sharing the boards between players from different platforms becomes super easy. I just need to send over the seed number that started the game, and the board will look the same for an Android player and for an iOS player. Now, if I've made an error in my board generation logic somewhere, it's enough for me to just fix it once in my common module, build the app for both platforms, and the fix gets into both platforms at the same time. It works exactly the same. Now, imagine that someone wants to share a board with a player that doesn't have a mobile device, and it shares a link to the board, to the web, and I can have the same thing in JavaScript. Now, this is not a functional board. Also, you can see the numbers look differently because it's an older version that uses a different algorithm. But the idea is to be able to share this kind of link across all the platforms, and it just works in the same way. By the way, the JavaScript version and the iOS version are not interactive. That means you can't actually go and type numbers here. The Android version is the most complete, so you can actually play the game from start to end, and it works. Okay, what's next? Maybe let me show you quickly the storage part that I talked about. So here, again, we have this multi-platform plugin. This time, because we will be relying on Android interfaces, I am actually adding the Android library as plugin as well as in my presets. Instead of having JVM, I have a preset for Android, for JavaScript and iOS like previously. And if you go into my source sets, you can see I have an Android main, a common main, and an iOS main. And like I said, in the common code, all I do is I define the interface of my class with the expect keyword, and then for Android, I can have the actual implementation. For Kotlin is the same, and for JavaScript, I can show you that even. Like I said, I'm using the Kotlin browser.local storage. Now I have a storage solution that works across all platforms. Okay, let's go back. So what about Kotlin native? Is it really that easy to share all of your code with iOS? Well, there are some gotchas. Kotlin native, the version of Kotlin that compiles down to machine code that interacts with Objective-C and Swift and runs on iOS, for example, is a little bit different than something that we know from Kotlin JVM or even from running native code compiled from C or C++. First of all, it has a completely different memory and threading model. you don't really start threads or use threads from Kotlin native. There are no functions to do that. That said, you can use platform or SDK functions that exist on platforms like on iOS to start other threads. The problem is you can't really share objects created from Kotlin code between those threads unless you meet one of the two conditions. First of all, the data that you pass between threads has to be immutable. And there's a special method on every object in Kotlin native that's called freeze. And once you freeze that object, you can no longer mutate it. The nice thing is you can pass it between threads. The other way to do it is make sure you have a self-contained object subgraph. And if you detach it, you get a memory pointer. You can pass that to a different thread. And that's a way to go around it. Now, there is a way of running background operations, and that's workers. That's specific to Kotlin native. And again, you still need to abide by the two rules. Whatever you pass into the worker or back from the worker has to be either immutable or in a detached state. And if you're thinking about coroutines that could save you from all of this, yes, coroutines are available on Kotlin native. However, because of the difficulties with the threading model, they are single-threaded for now. And that might change, that might not change. We don't know yet. There's an issue on the coroutines repository on GitHub that discusses this at length, and they're currently thinking of how to solve it for Kotlin native. That said, actually interop between something like Objective-C or Swift and Kotlin native is actually pretty good. Now, I've never done any Swift coding before in my life, but I did have to implement the top layers of my app, so the view and the view controller in Swift, and it was actually pretty easy. Coming from Kotlin, the syntax is similar. I could just use my Kotlin native objects that I defined in my Kotlin code from Swift as I would any other object. There's a lot of interop kind of object translations happening. It takes a little getting used to, but it actually works pretty well. The one thing that I hit that was a speed bump for me was that you can only have a single Kotlin framework. So it's the artifact that you build from your Gradle build from Kotlin. You can only have a single Kotlin framework in an iOS project. So at first I thought, let's modularize everything as much as I can. Like, for example, my storage solution, it's a self-contained library, right? All it does, it provides you a library for saving key values. Why not make it an iOS framework that I can use in any iOS app, and then have a similar iOS framework for my other Sudoku code? It turns out if I connect two Kotlin native generated frameworks to an iOS app, I get duplicate methods, duplicate classes. It just doesn't work. That's why in my Gradle structure, I have one top-level Kotlin native solution that builds one framework, and it depends on all of the modules that I have. Okay, and if you do look at my sample later, just be aware that the proper architecture, this is still more or less work in progress. Like I said, this is me exploring Kotlin Multiplatform projects. This is me learning iOS as well. So architecture is a bit in flux right now. Now on the Android side, it's actually, I think, pretty okay. I just use coroutines to do some background operations, like generating a Sudoku board actually takes a few seconds, so we need to do it on a background thread, not to hang the UI. It actually works pretty well. On iOS, I'm still figuring it out, thanks to the different threading and memory model. However, I was able to start moving some of my classes to shared code. So I have a local board source, I have a generated board source. These don't actually depend on any platform-specific interfaces, although they do use the modules that I have in the lower levels of my application stack to work, such as storage, persistence, and so on. I was able to move them to common code. However, my board repository, just because of the coroutines problem, I still have one implemented for Android, and one using an ugly hack and dispatch queues on iOS for background work. That's iOS only. The next step would probably be for me to figure out if I can somehow have one repository that I can use from both my Android view model and iOS view controller. So this is more or less how my app looks like now, right now. So there is a Swift part. I have native implementations of views for both platforms. Now, one thing I noticed when I was building it as well was that I have to draw the Sudoku board on the screen. The grid, the numbers, everything, and why do it twice? It's just drawing operations on a canvas. Now, yes, I do want to have native views on both platforms that can fit in a native Android view hierarchy. Same on iOS, that respond to input events in the Android way, in the iOS way. However, ultimately, both views have a draw method, right? And they get a canvas on the Android side. They get a graphics context on the iOS side. And I was actually able to pull out my drawing operations to draw the grid, which is essentially just draw line, draw line, draw line. Same for horizontal lines, and then drawing some text. And I was able to build a very simple, very limited functionality canvas library that takes a canvas on Android, a graphics context on iOS, and draws that. And that's why in my code, when I go to something like, where's my lib Sudoku? No, let's show you actually the X code, maybe. Yes. So here I have my board view. It's Swift code. It's a UI view, native to iOS. However, in this draw method, literally all it does, it calls my Sudoku renderer that's from Kotlin, draw board with the width, the height of the view, and all of the drawing happens in common code. Now, when I did that, it works. My board looks exactly the same across platforms. However, I started wondering if I went too far. Like I was telling you that I want to have the native feel, and I want to share as much code as makes sense across platforms. And it's up to you to decide. For me, it works for this project, but maybe going up as high as sharing UI and sharing the drawing, maybe that's just taking it too far. But still, you can look at the code, see the implementation. Again, you can learn how the actual and expects mechanism works, how you can build one canvas with one interface that actually draws on different platforms using different graphics contexts. Okay, so the code is here. It's very much work in progress. I keep changing stuff, tweaking stuff. But if you want to learn the basics of Kotlin Multiplatform on a fairly simple project with a common module with just maths operations, and then a simple storage module that actually provides implementations for different platforms. There's an iOS project that you can open in Xcode in there. It's the top level is an Android project. That's a normal Gradle project you can open in Android Studio. Feel free to try it out, and I'm happy to hear any feedback you have. Now, I think this is a very promising technology. It's not something, as coming from Google, I'm not telling you to now go and build your apps in Kotlin Multiplatform right now. There's a lot to be done from all sides, from JetBrains side, from Android Studio side, to provide you with good tooling, with good libraries, with good guidance on how to actually do it, what to share, how to share it. However, I think it is a promising start. And thinking about all the cross-platform toolkits that I've encountered before, I think I'm going to invest my time in learning this better. And I think this has a chance of really letting you build top quality apps for Android and for iOS, while at the same time saving time on the shared code, on the shared bugs that you have to fix, on the shared business logic that you can build once and then run in both apps natively. Okay, thanks, and time for questions.